Hi, this is Rick for EDU Mobile. Welcome to Unit 2. We're going to start Unit 2 by talking about three kinds of things in Swift. Enumerations, which is this discussion, structures, and classes. Enumeration structures and classes in Swift share some very important concepts. So along the way, we're going to get an idea of property syntax in these structures and method syntax as well. Because in Swift, enumerations and structures also may have methods, which is unlike Objective-C or probably anything else you're used to working with. So without further ado, we're going to start talking about enumerations. In this discussion, however, we're going to have more other information that we're going to build upon when we talk about structures and classes as well. So first of all, these are not the C enumerations you may be used to dealing with. C enumerations are very simple. In C, an enumeration is just a set of names for integers. It's just an alias for a bunch of integer names. So in C, we could have enum days equals Sunday through Saturday. And we know, or you may know, that Sunday would take on the value of 0 unless we established a different value for it. But internally, a C compiler treats Sunday as 0, Monday as 1, and so forth. I should say most C compilers do that, even though documentation will tell you don't rely on a particular value unless you set one. We're not talking about C, we're talking about Swift. But in C, we could force a value on a member of an enumeration, something like enumeration of suit, clubs 1, diamonds 2, hearts 4, spades 8. We can do that in Swift as well. But basically, all we're doing in C with an enumeration is defining a type that contains aliases for integer values. And if we're talking about C, we would stop right there because that's all you need to know. But we're not talking about C, we're talking about Swift. These are Swift enumerations. Swift enumerations are very powerful, and there's some subtle things going on that you need to be aware of. In Swift, an enumeration relates a type to a group of values, and it maintains type safety while it's doing that. Swift enumerations don't have to have a value for every member. In fact, most of the time we're dealing with Swift, we treat these enumerations as subtypes of a given type. But if they do have a value, that value can be of any value type, strings, characters, ints, or any subtype, or doubles or floats. Values provided to the members of an enumeration, though, are known as raw values. So if we do provide values, these are called raw values, and we can get them back if we have raw values in an enumeration. We set it up properly. We can get those values back by using a method toRaw. But wait, there's more. Enumerations can define values to be associated along with any member of an enumeration. And the associated values now can be of any type. Those associated values don't have to be one of the character, string, boolean, integer, double, or subtypes. They can be anything. Also, enumerations can have computed properties, and they can also have instance methods. They can adopt protocols. They can define initializers, aka constructors, to set themselves up. You can extend an enumeration. So really, you might be thinking now, this is starting to really kind of look like a class, but it's really not. It's not quite a class. In Swift, enumerations and structures are not classes, they are value types, whereas classes in Swift are reference types. So what am I talking about here? A value type is a type that when it is assigned or passed to a function, its actual value, the value inside it, is copied. So for example, we've seen this example before. You've seen this in other programming languages. It's very basic, but it's telling us something about value types. Let's say we set up two variables. The first variable we're setting up to be an integer 35. Its type is inferred to be 35. The second variable we're setting up equal to num1 because num1 is an int, num2 is inferred to be an int. So num2 now actually holds the value of 35. With a value type, which is what ints are, num2, if we modify it, let's say num2 equal 28, num1 is still 35. We expect this kind of behavior with value types. Everything we have dealt with so far is a value type. If we do this with doubles, if we do it with strings, if we copy one into another one, modify the other one, the first one's value stays the same. Well, behind the scenes, all of the things, ints, double strings, everything we've talked about so far, including arrays and dictionaries, these are all value types. So if you copy them to another variable of the same type and modify the second variable, the first variable remains unchanged. If you pass them to a function, you are passing the value, not the actual thing. Unless you pass them as an in-out parameter. But that's kind of cheating because that's passing a value type as a reference type. The only important difference between structures and classes is that classes are reference types. If you copy them, it makes a deep copy. Now, if you change the copy, it changes the original. Okay, so we're getting ahead of ourselves a little bit. Just know that enumerations are value types. Therefore, they are not reference types. Therefore, they are not classes. But in Swift, enumerations can have properties, computed properties. They can have methods, and they can adopt protocols, and they can do everything that a class would be able to do, except it's not a class because it's a value type. So here's how we declare an enumeration. In this case, I have a rather lame enumeration called silverware. And there are three kinds of silverware. Knife, fork, and spoon each have a case. And a case says this is the beginning of a member declaration for an enumeration called silverware. Notice that everything is uppercase here. Silverware is a type. Knife, fork, and spoon are members, aka subtypes, of silverware. Each case starts a new member definition. Use capital letters for enumeration types and their member types because they are really types. It's kind of a C convention or an Objective-C convention, and it certainly is a Swift convention that we use uppercase letters to denote types. So you can assign a variable or constant to any member of an enumeration. So let's create a variable called utensil. It is created as a silverware.fork. All right, so it's one particular type of silverware. It is silverware whose member is a fork. So now we can say if food is equal to pudding, assuming that food is defined beforehand, we say utensil equal spoon. Now, why can we say .spoon instead of silverware.spoon? Well, because utensil was set up in its var definition as a type of silverware. So once we have done that, we can use this shorthand, .spoon, to just change that type. Else, if food equals butter, we want to use a knife because a fork couldn't work as well with butter. Once the type of a utensil is known, we can use the shorthand assignment syntax to change its value. Very good. We can also check for the value of a member. We can use a switch statement to determine which member is currently set of utensil. So we can switch on utensil. We're not switching on utensil dot anything or utensil dot membership or anything weird like that. We just switch on the variable. So if it's case.knife, we can print line careful it's sharp, and we can do all of these things. This has the same restrictions as any other switch statement. In other words, according to the compiler errors you get, it must be exhaustive. We have to check every case. But we can also use a default case in case we want to only look at one or two things. Let's say we wanted to know if it was a knife only. Careful it's sharp. In the default case, we really don't care what we do. We could do that. We can also associate values with members of an enumeration. So here's an enumeration that looks a little bit different. We have a car and a bicycle, and the enumeration is called vehicle. So we can have a vehicle that is a car or a vehicle that is a bicycle. In the case of a car, we want to have further associated values with it. An integer for the year, a string for the make, and a string for the model. In the case of a bicycle, we really don't care about that. All we really care about is how many speeds it has, or gears. So we have an n. Assignment will create either a car or a bicycle with the associated values. So we can make a variable myRide that is a vehicle.car, passing it 1964, Ford, and Mustang. Now, you can think about this as kind of an initializer for a vehicle car, but really what you're doing is setting up a tuple here, and you're passing values into that tuple. So you can change the membership of a myRide to a bicycle, in which case you can just say 10. This is a 10-speed bicycle. You can say a 3-speed bicycle, or whatever you want to do. myRide's type here is vehicle. Vehicle's members are either a car or a bicycle. A car has 3 associated types with it: the year, the make, and the model. A bicycle only has 1 associated type with it, and that's how many speeds it has. So if you're familiar with the concept of a union in C or a variant in some other language, this is the same thing. So we don't have to set up some kind of weird structure to do this. We can just have an enumeration with associated types. Pretty neat. Let's keep going. We can switch on those associated values, and look how we do this. We have a car. Let's say myRide is a car. So in the case that myRide is a car, we can say let year, let make, let model. Now, year, make, and model, we're just throwing out there here. We're naming them here, just like we can do with any tuple. So we can print line year, make, and model. So this might say 1964 Ford Mustang. We'll have to cover the bicycle case too, but I'm leaving that out just to save kind of room on the slide. We can use a let or a var. If we're going to modify things, we can use a var. So we could have said var year, var make, let model. But if you're letting or varring all of the types, regardless of what type they are, you can factor the let or the var out. So we could say case let.car year, make, model. That would do the same thing that we've done here up above. Now let's talk about raw values a little bit. A member of an enumeration can have a constant value assigned, any constant value assigned, any of those character, string, double, int, bool, any of things like that. It can have a constant value assigned when the enumeration is created. So we have an enumeration here, radian, and it just says, okay, what's the radian measure for these 3 things? So the radian measure for a full circle is 2 times pi. For 180 degrees is pi, and for 90 degrees is pi over 2. So 2 times pi, and pi over 2 are raw values that we have assigned to circle, deg 180, and deg 90. The members of radian will always have these particular values, and these are called raw values of the enumeration. Now, I should say that there's a slight error on this slide. With an enumeration with raw values, all of these values, let's say, are doubles. They would be doubles because pi is involved. We would have to say enum radian colon double. So we have to type the enumeration with the same type as the raw values that are allowed in the members of the enumeration. We'll see this in the demo as well, and I'll point this out. So let's look ahead a little bit. We've talked about how to set up enumerations. Enumerations, like classes and structures we have already said, can have instance method. In the case of enumerations, one neat use of instance methods is to change the state or change the member, the currently selected member of the enumeration. We call this mutating. And there is a mutating keyword that goes before function in one of these method definitions to tell the enumeration that this particular method is a mutating method. So a mutating method, once again, is one that changes the value of self in the enumeration. So self in the enumeration actually refers to that enumeration's current membership. So self in the enumeration, in this particular case, is referring to an enumeration's members, which member I currently am. Hope that makes sense, and it will make sense in the demo. So here's an example. Here's a traffic light, and it has 3 states. It can be red, green, or amber. And those 3 states are the members of the traffic light enumeration. Notice that we have a mutating func change. Now, in the context of an enumeration or a structure or a class, a function is a method. So we have this mutating method change. Notice there is no method keyword here. It's func. It's a function. So we're going to switch on self. If we are red, that's what that says. If self is red, self equal green. In other words, when a stoplight is red, the next state will be green. When the stoplight is green, the next state will be amber. And when the stoplight is amber, the next state will be red. So that's all we're doing. And what we've done here is defined an enumeration that has 3 states that knows how to go from one state to another. In other words, it's deterministic and it's reversible. It's a good physical traffic light. So let's define a traffic light, 9th and Main. And we're just saying arbitrarily that this traffic light at the time of definition is green. We can say 9th and Main dot change, and that will change from green to amber. If we call it again, it'll change from amber to red, and if we call it again, it'll go back to green. It'll say I am currently red, self equal green. Thank you very much.